Hello everyone, welcome to the lecture series on Foundations of Deep Learning Concepts and Applications. Today we are in the last session of our week 6 where we had started with the object detection, and then we have also seen the segmentation based algorithms. We have seen UNet. Yeah, so let us get started with the hands on, and here we will be seeing the object detection using YOLO. So, the entire this hands on is divided it into 3 sections, where although you have already seen the hands the theoretical part of YOLO, we will quickly recall a few important concepts which are required from a practical perspective, and then we will see how object detection can be done using a pre-trained YOLO models, and if at all if we have our own data set. On our data set, how do we go for an object detection? So, these are the 3 points that we will be discussing. So, the very first step, since we are doing it in Google Colab, you will be mounting the drive. You will be linking to the Google drive. So, once this is done, a small theory part is here. The YOLO architecture is proposed in the year 2015 by Joseph and team, and the YOLO architecture is completely a CNN based architecture only. And YOLO V8, which we will be seeing in today's session, it was released in the year 2023 January, and in 2024 we have YOLO 11 version, in 2025 we have YOLO 12 version, and YOLO 12 is the latest release of this particular family. Originally this YOLO architecture, you only look once, the full form of this was originally meant for object detection, but it has evolved to perform image classification. We can even perform the segmentation, image segmentation as well. So, let us see how we are going to implement. So, this what you are seeing on the screen, this is most important concept in case if you are using an standard built-in package. So, here under classification we have YOLO 8. For this particular session we are using YOLO 8 model. So, YOLO 8 is the 8th version of it. N-CLS. CLS stands for you are doing you are using YOLO for a classification task. So, we are using YOLO version 8 and classification. Now, what is this N and what is SM is, now what model you want to use, that depends on what is the kind, what is the size of the data set that we have. So, here you see nano, N stands for nano. Suppose if the size of our data set is extremely small, then we can go for YOLO 8N classification model. If our data set is a small data set, then we will use S. If our data set is medium, we will be using M. If our data set is large, we will be using L, and if our data set is really huge, we will be writing it as X. So, this is what this is how we need to understand. And what are all of these? These are the standard classification models that we have. Next, if your intention is to go for a detection, if your problem statement is a detection based problem statement, then if your data set is small, go extremely small, go for nano. Small is S, medium, large, and huge data set. And here see the difference between the first this and this. Here we are the CLS is explicitly if we are going for a classification part. Here if you do not have any such extension, that is you do not have any hyphen part here, which means it is used for an object detection. Now, the same if you want to go for a segmentation, then you will be writing hyphen SEG. So these are pre-trained YOLO models. You can use based on your problem statement, you can use any one of this model. So this is just for your knowledge purpose. Now the very first step, if at all, if you are dealing with YOLO, the first step is you have to install Ultralytics. So pip install Ultralytics. Why is that this is required? Because YOLO is a part of Ultralytics. So first install pip install Ultralytics. And YOLO is one such architecture which is trained on COCO dataset. So we have around 80 objects in this. So on this COCO dataset, the YOLO model is being built, and all the above YOLO models, whatever we have seen, all these YOLO models are built or trained on COCO dataset only. Okay, so once we install pip install Ultralytics, the next step, it will take a few seconds for installation. Once we install, then the next step is you will be importing YOLO. So from Ultralytics, we will import YOLO. So now you can ask, we are more specifically working on version 8, no problem, still import YOLO only. From where will we import? From Ultralytics. So if you directly run this without installing Ultralytics, you will see an error here. So first step, install the Ultralytics, after that you import the YOLO. And here is where we are calling the the actual model that we are pre-trained model. So from YOLO we are taking the medium sized model, and what model we are using, since there are no -CLS or -SEG, which means we are using the model which is meant for detection, object detection. So YOLO, from YOLO call this particular model. So assign it to a variable model. This also when you execute, it is going to take all the pre-trained the weights will get downloaded, and you are going to assign it to a variable model. Right. So once this is done, you want to visualize, you want to see how do the YOLO architecture looks like. So then print the model, print this model whatever you have assigned to, print that, and then also see, you can see what is the type of that particular model. So this is what is the YOLO architecture. It's a very huge architecture. Since it is a CNN based, you will be able to see all convolution operation, batch normalization. So all this is an YOLO architecture. So I am not repeating it once again because you would have seen this in a theory session. So this is the YOLO architecture. All this is an YOLO. It's a very huge model. So once the YOLO model is been printed, you are also asked to print the type, right? You can see the type of this is Ultralytics models YOLO model, YOLO. So this is the type of the model. Next, you are calling all the necessary packages. So NumPy as NP, computer vision, so CV2 is open CV. This is required in order to do certain tasks. We will see what are those tasks. If you want to visualize some images, so or you want to read an image, we will use CV2. And then this is for plotting the images, and then since we are importing since we are implementing this using a PyTorch, we are importing a torch here. Then so once the model is being trained using a COCO data set, now we want to test one image. So since it is on COCO, there are 80 such different classes that are a part of this. We have lot many animals, objects, then we have vehicles, there are many. You can Google it and then you can understand about the COCO dataset. So, I want to test one sample image. So, whatever the objects which are present in that 80. So, any image which has those 80 classes, 80 objects, you can take that one image for testing. So, I have taken an image which is having a cat and a dog. So, it is stored in the drive and I have mounted and have copy pasted the path of that particular image. So, store it in an variable test underscore image underscore path. You can ask the question, ma'am, where have we used our data set? Because it is a standard pre-trained model, it is already trained on COCO data set. So, now we are only testing our model. For testing, we have taken one random image, an image which is having cat and dog. I will display that image in the further. Now, we have to first read the image. So, cv2.imread, imread is a function which is used to read an image and it is an function which is a part of cv2. Therefore, we have imported cv2. So, pass this image and read this particular image and store the result in a test underscore image. Now, first print the shape of it and then display the image, whatever the image that we have taken, we want to display it. So, I am show. So, you see whatever shape always gives us the width, height, width and dimension of an image and number of channels. Here this is the size of the image 415612 and the channel here is 3, which means it is a colored image. So, this is what the sample image that we have taken. We have a cat and we have a dog as well. Now, what is the next step? Once the image you have taken, you have read, now whatever the model that we have taken, using that model you have to predict it. So, model dot predict. So, this will give us the result. Now, predict what is that it has to predict? It has to predict the test image. Here is where we have a test image. After reading, it is stored in a variable test underscore image. Therefore, model dot predict, you are passing a test underscore image and the results are stored in a variable results and then go print the type of the results. So, here the type of the result is list. This is the type of the result and most important, understand what it is. Now, we have just printed the type, but we have not actually seen what is, once the model predicts, what is that the model has predicted. We did not see that yet. So, now print what is stored in that variable results. Very, very important. I request everyone to focus here and then print the length of it also. Now, what is stored in the results? You see, can you able to see this? These are all the things which are stored in a variable results. So, in the variable results, the very first, it is stored in the form of a dictionary where we have a key as well as the value. This is the key and this is the value. So, the very first one is boxes. Very important, boxes. Then it has printed the names, it has printed, it has also given you the original underscore image. So, it has given so much of all this is being stored in a variable results. What is this results? Once we have predicted, model dot predict on this particular image, whatever the image that we have taken, when we predict, we have got some results and the results are stored and that result we are printing. So much we are able to see. Let us unbox each of these, let us try to understand. So, all these is what it has printed and see the length, what it has, the length of this result is only 1, which means this entire is only one list. Can you able to see? It is a list. It is a list. It is also giving you the speed it has taken to pre-process, infer, post-process, all that it is displaying. Now, the result, since there is only one variable, so that value which is stored in 0th location, that is assigned to a variable result. Okay. Now, print that result. It is once again you are going to see whatever is there in that particular list. Now, the most important thing starts from this point onwards. Very first, in the results, there was names also, right? Can you see here? There was names also. There was names also. Now, what does that 80 objects consist of? The first object here is a person, bicycle, car, motorcycle, aeroplane, bus, train, so on and so forth. So, the label given to a person is 0, bicycle is 1. So, here what is that we want? What are the labels that are there for our image? So, from result dot names, assign it to a variable class and then print its type length and print all its key and value pair. So, from class underscore names, take all the keys and then start printing the key as well as the value which is stored in that particular key. Just for a visualization, we are printing all the names. So, can you able to see 0 person, 1 bicycle. So, you are printing, you have taken the values and you have printed. You can ask why to do this. You will come to know shortly. So, here can you see the class names for our object. So, the image has cat and dog. Cat is having the class name, its number is 16 and for cat the number is 15 and for dog the number is 16. Can you able to see these two? Cat and dog are the two objects that we have in our image and we want to see what are its labels. So, one is 15 and 16. So, this is class ID and then the object name. So, the next step is you are taking from the result, you are printing original underscore image. So, can you able to see in the result you have a variable original underscore image. So, whatever is the image that the model has read, you are storing it in a variable. From the result you are taking this and then you are storing a copy of it and then you are printing the original image. So, what model has read you are able to you are printing here. So, next we have also a speed. So, you are same thing what we have done for the names, you are taking a speed and then you are taking you are assigning it to a variable computation underscore time and then you are taking the keys and key and value you are printing. Right. And the most important, please focus here, under results we have boxes also. Can you see we have boxes. This is very important. So, now we are printing boxes, we are trying to visualize what is there in the box. Result dot boxes. Right, assign it to a variable predictions, bounding underscore box underscore predictions, print its type and print the values which are there. Can you able to see what it has stored? So, can you see here? It the classes what it has printed is 16 and 15. Now, can you able to correlate why did we printed the names? Because our object is having a cat and a dog. So, model is saying that your image is having the label, the class ID is 16 and 15. Now, we do not know what is that 16 and 15. To understand, we have printed this particular cell. Why did we do this? In order to understand what is there in 15 and 16. To know, we have done this part. Otherwise, ideally, this cell is really not required. Just for us to know what exactly is 15 and 16. we have printed that. So, boxes, when you give from the result, when you print the boxes, what all information this boxes hold. So, the first information that the boxes hold is what are the classes that are present in the image. The classes that are present in the image are 16 and 15. Now, what is the confidence with which the model has said that it is a cat and a dog? So, CONF is the confidence with which the model said the object is dog and the object is cat. What is the confidence with which it has predicted? Is 94.50, 91.31. This is the confidence with which the model is saying that in your image there is a cat and a dog. And what is the confidence level? The confidence level is 94 and 91. Then what are the bounding boxes? Now it is an object detection. For an object detection, we should draw the bounding boxes, right, around the object. So the model has drawn the bounding box. From the theory session, you would have seen the bounding box will have totally 4 coordinates. You will have top left and bottom right. So you will have totally 4 coordinates. So these are the 4 coordinates of the bounding box for the class 16 and the confidence with which the model has predicted. Then under data there are 2 objects, right. So there are 2 bounding boxes for one bounding box for one object, and the confidence with which the model has predicted and the class that the model has predicted. See, look at this, all this are the information which is present in the variable boxes, right. And look at this, the size here is 2 cross 6. What is this 2? There are 2 such variable 2 such values, and 6 here is 4 coordinates, the confidence 5th one and the class ID 6. That is what is 2 cross 6, and shape the image size. Now, the model in that boxes, it is also going to return the bounding box in 4 different formats. So, what is the first format? The xy coordinates, the width and height. From theory session you should be able to recall xy width and height. Xy width height in a normalized form. Then this is xy, then xy in normalized form. What is all these? These are, can you able to see, for our given image, for whatever the image that we have passed as an input, the model has given the bounding box coordinates. Now, that bounding box, in which format the bounding box coordinates have been given? Can you see 261? Can you see here? It is matching with this format. So, whatever the bounding box that the model has returned is actually matching with this format, which means it has returned in the format xy, right. So, now the next step is, this is all the output that the model has predicted, but we want to visualize that bounding box. So, this part of the cell is mainly for visualization. So, CV2 underscore IM show import from this particular collab patches. Then your bounding box is in XY format, right. So, this bounding underscore box underscore predictions, the entire result of boxes is stored in this. In that, more specifically, we are taking XY. We are taking xy and assign it to one more variable called coordinates. Print the type of this coordinates, and you will definitely have its type as a tensor. Can you see? Its type is a tensor. Why its type is tensor? Can you go back? xy, can you see there is a word tensor. So, it is of a type tensor. Now, we do not want it in a tensor form, we want it to be in a list. So, convert it explicitly to list, so that you now have all those values in a list format. Print its length. So, definitely the length once you print its length, then you are going to draw the bounding box. You want to visualize that bounding box. So, since the length is 2, you are taking the index 0. So, the first one 0 1. So, the first box underscore index will be 0. So, 0 plus 1, it is 1. So, we are showing the bounding box for 1. So, first all at the 0th location, whatever the coordinates that we have, bounding box coordinates, you will take all those values and you assign it to a variable x1, y1, x2, y2. Here the values are in terms of decimals, right, 261.0996. Since it is in the decimal, we are explicitly converting that into integer type. All this you are converting it into integer. After that, you are drawing a rectangle. So, what should be the coordinates of the where you want to draw this rectangle onto our original test image. Then what are the coordinates? The top left, bottom right coordinates. And when you draw the bounding box, what should be the color of that bounding box? So, it is R, G and B. R is 0, G is 255, B is 0. That means the bounding box color is green, and 2 indicates what is the thickness of that bounding box. So, all that CV2 rectangle is a function which is used to draw the rectangular bounding box and then show the original image. So, can you able to see? You have printed the bounding box. So, that x1, y1 is the coordinates, x2, y2 are the coordinates, RGB 0, 255, 0, 0 is R 0. So, that means red is not there. For green you have given 255, which means it is full green, and blue is 0, and 2 indicates the thickness of this border. And since there are 2 such values, right, here you will be repeating it, you have put everything in the for loop, and here there are 2 such objects. So, in our list there are 2 values. Therefore, for the first one you have printed, again the control will go back to this for loop. Again you are going to take the value here, box underscore index, the value will be 1 now, 1 plus 1 it is 2, and in the index value 1, whatever the values are there, assign it to this, once again convert everything into integer. Can you able to see? This is the second one. These are the bounding box coordinates. Can you able to see this? Okay. Now, you can ask the question, so this is all about object detection using YOLO. Most important, one has to understand here. Now, you have your own data set. For that data set, you want to, I do not want to use such a simple one. I do not want to use an, cat, dog. I have taken an I was going on the road, I have just taken a picture, and now it has to identify where is a street light. Where are human beings, where are cars, where are bikes, where are pedestrian, where are trees. I want the object to, I want the algorithm to identify such problem statements. We do not want cat and dog. Or on our own data set, we want to use YOLO. If that is the case, how is that we have to do it? So, when you have to use your own on your own data set, the very first step is you have to prepare your data set. Okay. Most important is sometime back you have seen how to prepare a data set. So, there you have seen how to create an YAML file. So, you have to take only that YAML file and then paste it here. Can you, the model what we are taking is still YOLO V8 only. Take that YOLO V8 model and now you have to train on your customized data. How do you tell the customized data? So, you have to pass the data set also, right. So, in the data set you will not pass the complete train test, nothing. You will just pass only that YAML file that you have learned how to do it. Sometime back you have seen this session, how to create an YAML file. Just paste this YAML file path here, and for how many ever epochs that you want to run, you run it. Ultimately, when you run this epoch, it is going to show how many images are there in training. It will load all the images of training, it will load all the images of test, then it is ready for the execution. It will be, it will, now during testing you can pass an image, it will be able to do it. So, the last part what you have seen here is, if you want to create, if you want to work on your own data set, all you need to pass is YAML file you need to pass, and you need to train this YAML file. So, once you do this, then rest everything will be the same as above code. So, whatever you have seen, all these will repeat. So, using that model, you will predict, pass the test image. One second, I will just scroll up. Yeah. So, you will using from this line onwards, the rest of the things will repeat. Model dot predict, pass that test image here. So, take one random test image. Once your model is trained on custom data set, take one image, and then rest all of this line will remain the same. So, only one change is when you are working on your test on your own data set. Most important is all about this creating YAML file, and you need to train this YAML file using you can still go ahead with the pre-trained model only, that is YOLO. So, this is all about the week 10. In this particular week, we have seen the object detection algorithms, object segmentation, image segmentation algorithms. We have seen an hands-on implementation on segmentation, that is unit based, we have seen hands-on. Today in this particular session, we have seen object detection, and most important, you have also learned on how to create the custom data set. If you are if you want to work on object detection, how to create the YAML file, that is also is being learned. There are many ways to create to prepare a data set, but what we have shown you is using an label IMG. Otherwise, there are so many other ways you can create the data set. Thank you.